the chillest spot for IT walkthroughs and reviews, Tech Stack Lounge.
Welcome back to Tech Stack Lounge, where we try to make even the most complicated tech topics feel like a comfy chat on your couch.
Yeah. No jargon overload here.
Right.
Just clear explanations and maybe even a few aha moments along the way.
Absolutely. And today we're taking a deep dive into something that you use every single day, but you probably haven't given too much thought to.
Right.
It's the underlying structure that makes the internet tick.
Okay.
The OSI model.
The OSI model.
Yeah, so you think of it kind of like the unsung hero of the digital world, right?
Yeah, absolutely.
Like it's the reason you can stream your favorite shows or send emails across the globe, or even listen to this deep dive right now.
Right now.
So, okay, OSI model. It sounds a bit like
It does.
something you'd find in like a dusty computer science textbook.
Yeah.
You know?
Yeah.
What's the story here? What problem was it even trying to solve?
Well, imagine a world where every computer network was like a separate country,
Okay.
speaking its own language. You couldn't send an email from an IBM machine to a DEC machine. It was chaos.
So basically the internet's version of the Tower of Babel.
Exactly.
Okay.
The OSI model was created to be the universal translator, right? A common language for all these different systems to communicate.
Okay.
And it did this by breaking down network communication into 7 distinct layers.
Okay, 7 layers.
7 layers.
That sounds a bit like a complicated cake.
Yeah, it can be a little intimidating at first.
Is it really necessary to have so many layers?
Oh,
Why not just, like, simplify things a bit?
that's a good question.
Yeah.
It's all about organization and flexibility.
Okay.
Think about it. If you were designing a house,
Right.
you wouldn't just throw all the materials together in a pile
No.
and hope for the best, right?
Well, no.
You'd have a plan, different layers for the foundation, the walls, the plumbing, electrical.
Right. You'd have blueprints.
Exactly.
Right.
The OSI model does the same thing for network communication.
Okay.
Each layer has a specific job, and they work together seamlessly
Right.
to transmit that data from point A to point B.
Okay.
Plus, having these distinct layers means that each one can be updated and improved
Right.
without messing up the entire system.
Gotcha. So you're not, like, breaking the whole thing every time you got to go in and fix something, right?
Right.
Okay. I'm starting to see the value of this layered approach,
Good.
but 7 layers still seem like a lot to wrap my head around.
Sure.
Where do we even start?
Well, let's start with the foundation,
Okay.
the ground floor of the OSI model,
Okay.
the physical layer.
The physical layer. All right.
This is where things get tangible.
Okay.
We're talking about the actual physical stuff that carries the data,
Right.
cables, radio waves, fiber optic lines, all that good stuff.
So the physical layer is all about the infrastructure, the actual roads and highways for data packets?
Yes. And it defines all the nitty-gritty details of how data is transmitted over these physical mediums. Things like voltage levels, connector types, signaling speeds.
Yeah.
Think of it as the nuts and bolts that hold the internet together.
Okay, that makes sense.
Yeah.
But once the data is on these highways, how does it know where to go?
Right.
It's not like data packets have built-in GPS, right?
Well, not exactly built-in GPS, but they do have something similar.
Okay.
That's where the next layer up comes in, the data link layer.
Data link layer.
It's like the traffic cop of the network,
Okay.
making sure data gets to the right device on a local network.
Directing traffic, I can imagine that gets pretty complicated.
It definitely can.
Yeah.
This layer uses hardware addresses called MC addresses, which are unique to each device on the network. Think of it like the street address on an envelope,
Right.
ensuring the letter gets delivered to the right house.
So the data link layer is all about local delivery, making sure data gets to the right device within a specific network.
You got it.
Okay.
And it also does some error checking.
Error checking.
I
Interesting.
remember those old dial-up modems
Oh, yeah.
where the connection would drop
Yeah.
if there was too much noise on the line?
Oh, yeah. The good old days of screeching modems
Yeah,
and dropped connections.
exactly.
Yeah.
The data link layer helps prevent those issues
Okay.
by ensuring data arrives without errors.
Gotcha.
It's like a proofreader for your data,
Okay.
correcting any typos along the way.
So we've got the physical connections, we've got
Right.
the local delivery sorted. But what about sending data across the vast expanse of the internet?
Right.
That's where things must get really interesting.
That is where things get really interesting.
Yeah.
Yeah, that's where we enter the realm of the internet's postal service, the network layer.
Okay.
This is the layer that figures out the best route for your data to travel across multiple networks.
Okay.
Like a seasoned traveler with a well-worn map.
So it's like a GPS for data.
Exactly.
Finding the most efficient path through the internet's tangled web of connections.
Yeah, it uses IP addresses, which are like global addresses for devices,
Right.
to figure out where your data needs to go.
Okay.
It's a bit like sending a letter. You don't need to know the exact route the postal service will take.
Right.
You just need the destination address.
Okay, so the network layer gets our data across the country, maybe even the world,
Right.
but what happens when it arrives?
Right.
I imagine it doesn't just magically appear in the right application on the receiving device.
You're right. There's still more work to be done.
Okay.
Just like your friend needs to open the envelope and read the letter,
Right.
the data needs to be delivered to the right application on the receiving device.
Good.
That's the job of the transport layer.
Just transport layer, okay.
It ensures that the data gets delivered to the right application reliably
Okay.
and in the right order.
Gotcha.
It also manages the flow of data, making sure the sender doesn't overwhelm the receiver with too much information at once.
I can see how that would be important, especially with things like streaming video, right?
Yes.
You wouldn't want the video to freeze up because the data is arriving too quickly
Exactly.
for your internet connection to handle.
It's all about maintaining a smooth and reliable connection.
Right.
And different protocols are used depending on the type of data being sent
Okay.
and the level of reliability needed.
Wait, different protocols. You're going to have to explain that one.
Sure. Think of it like choosing between sending a registered letter
Okay.
or a postcard.
Okay.
A registered letter requires a signature upon delivery,
Right.
guaranteeing that it reached its destination.
Okay.
That's like TCP,
TCP.
Transmission Control Protocol.
Okay.
It's reliable, but a bit slower
Okay.
because of all the error checking and acknowledgments back and forth.
So that makes sense for important things like emails or financial transactions, right?
Yes.
Where you absolutely need to know the data arrived safely.
Exactly.
What about the postcard analogy?
A postcard is faster and lighter, but there's no guarantee it'll arrive.
Right.
That's like UDP,
Okay.
User Datagram Protocol.
UDP. All right.
It's faster and more efficient,
Okay.
but doesn't have the same level of reliability as TCP.
Gotcha.
It's often used for things like streaming video
Right.
or online gaming where speed is more important
Right.
than guaranteed delivery.
So TCP for reliability, UDP for speed.
You got it.
Got it. This transport layer sounded pretty important.
It is.
What comes after that?
Well, now we move into the realm of managing the actual conversation between applications.
Okay.
That's the job of the session layer.
A conversation.
Yes.
Are you saying my apps are secretly chatting it up behind my back?
Huh. It's not quite like that.
Okay.
Think of it more like setting up and managing a phone call.
Okay.
The session layer establishes, coordinates, and eventually tears down
Okay.
the connection between two applications.
Gotcha.
It handles things like authentication, making sure the right users are connected,
Okay.
and it can even manage checkpoints.
Interesting.
So if the connection is interrupted, it can resume from where it left off.
So it's like the stage manager of the network,
Exactly.
making sure the show runs smoothly behind the scenes.
It's all about ensuring a seamless and uninterrupted flow of communication
Okay.
between applications.
Okay, session layer, check.
Check.
What's next in our OSI model journey?
Now we need to make sure the data is dressed for the occasion.
Okay.
That's where the presentation layer comes in.
The presentation layer.
It's all about data formatting, encryption,
Okay.
and making sure everything looks good and is understood by both parties.
So it's like the stylist of the network,
I like that analogy.
making sure the data is presentable before it goes out on the runway.
It handles things like data encryption to protect sensitive information.
Right.
It also takes care of data compression,
Okay.
which helps reduce the amount of data that needs to be transmitted,
Right.
making things faster and more efficient.
That's crucial, especially with all the security concerns these days.
Absolutely.
And compression is key for streaming high-quality video without buffering every few seconds.
The presentation layer also ensures that different systems can understand each other,
Okay.
even if they use different data formats or character sets.
Mm-hmm.
It's like a universal translator,
Right.
making sure everyone speaks the same language.
Okay, the presentation layer sounds like a pretty busy place.
It is.
What about the final layer?
Yes,
We're almost at the top of our OSI cake, right?
we are. And this is where it all comes together.
Okay.
The layer that you interact with directly. It's called
Okay.
the application layer.
Application layer.
And it's where all your favorite apps live and breathe.
So this is where things get really interesting for us users, right?
It is.
The apps that we use every day, like our web browser, email client, streaming services, they all operate at the application layer.
Exactly. It's the interface between you and the network,
Okay.
providing the tools and protocols for applications to access network services. Think of it like the storefront of the internet where you browse
Right.
and interact with all the information and services available.
This OSI model is quite the intricate system.
It is.
It's amazing how all these layers work together seamlessly to make the internet possible, right?
Right.
We've covered a lot of ground, from the physical cables
We have.
to the applications we use every day.
Mm-hmm.
I feel like I have a much better understanding of how it all works now.
Good. It really is a remarkable feat of engineering.
It is.
And while the OSI model itself isn't the only network model out there,
Right.
it's a fantastic tool for understanding how networks operate.
Okay, we've got a solid grasp on these 7 layers. But I remember you mentioned that the internet doesn't actually follow the OSI model perfectly.
You have a good memory.
Yeah.
You're right. The internet primarily uses a different model called TCP/IP,
TCP/IP.
which stands for Transmission Control Protocol Internet Protocol.
Okay.
It was developed around the same time as the OSI model, but with a more practical, less theoretical approach.
So it's less about creating the perfect model and more about getting things done.
Exactly.
And you know what? It worked, right?
It did.
TCP/IP became the foundation for the internet we know and love today.
Absolutely.
So is the OSI model just an outdated relic then?
No,
A museum piece of internet history?
not at all. While the internet doesn't strictly follow the OSI model,
Okay.
the concepts and layers still apply.
Right.
It's like having a blueprint.
Okay.
Even if the final building doesn't match the blueprint exactly,
Right.
the basic structure and principles are still there.
So it's more of a reference guide than a strict set of rules.
Precisely. The OSI model helps us understand how networks work,
Right.
even if the actual implementation is a bit different.
Okay.
It's a powerful tool for troubleshooting problems,
Right.
designing new networks,
Right.
and just having a common language to communicate about network concepts.
Okay, that makes sense.
Good.
But if TCP/IP is what actually runs the internet,
Right.
how does it compare to the OSI model?
Okay.
Are the layers the same?
They're similar but not identical.
Okay.
TCP/IP has 4 layers,
Okay.
which roughly correspond to the 7 layers of the OSI model.
4 layers, so it's a bit more streamlined.
Exactly. TCP/IP combines some of the OSI layers.
Okay.
For example, the application, presentation, and session layers of the OSI model
Right.
are all rolled into one application layer
Okay.
in TCP/IP.
Makes sense. I guess they figure why have 3 layers when one will do.
That's the pragmatic approach of TCP/IP.
Right.
It focuses on getting the job done efficiently,
Right.
and the internet wouldn't be what it is today without that practicality.
Okay, I'm starting to see the big picture now.
Good.
We got the OSI model, which is a great conceptual framework,
Mm-hmm.
and TCP/IP, which is the actual protocol suite that runs the internet.
Right.
But it all comes back to those fundamental layers, right?
Yes.
Those are the key to understanding how all this data gets moved around.
Absolutely. The layers provide structure and organization to
yeah.
what would otherwise be a chaotic mess of data flying around,
Right.
and to really appreciate how it all works.
Okay.
Let's walk through a real-world example.
Perfect. I love a good example. What have you got for us?
How about sending an email?
Okay.
Imagine you're sending an email to a friend overseas.
Right.
It seems like a simple action.
Yeah.
But there's a lot going on behind the scenes.
Okay, I'm game. Let's send that email and see what happens at each layer.
Great. So you open your email client
Oh,
and compose your message.
Okay.
This is happening in the application layer. You're interacting with the software
Right.
that lets you create and send emails.
Easy enough. What happens next?
The email then gets passed down to the presentation layer.
Okay.
Here, it gets formatted for transmission
Okay.
and might be encrypted for security.
So making sure it looks good and travels safely.
Exactly. Then it goes down to the session layer,
Okay.
which establishes a connection between your email client and the email server.
So like opening a communication channel.
That's right. Once the connection is established,
Okay.
the email goes to the transport layer.
Transport layer.
This layer breaks the email into smaller packets
Okay.
and adds information like sequence numbers
Right.
and error checking.
So it's getting the email ready for its big journey across the internet.
Exactly. And now it's time for the network layer.
The network layer. Okay.
This layer uses the IP addresses to figure out the best route for the packets to travel across the internet.
Like a complex system of roads and highways for data.
Yes. And at each stop along the way,
Okay.
the data link layer comes into play,
Yeah.
ensuring the packets are delivered to the correct device on the local network.
So it's like a local delivery service, making sure the package gets to the right house on the street.
Precisely. Finally, the packets reach your friend's email server.
Okay.
The process reverses, with the layers working together to reassemble the email and deliver it to their inbox.
Wow, that's amazing. All those layers working together
It is.
in the blink of an eye to send a simple email across the world.
It really highlights the complexity and brilliance of network communication.
It does.
And it all happens so seamlessly, we often take it for granted.
This has been a truly enlightening deep dive.
Yeah.
I feel like I've gained a whole new appreciation for the intricate workings of the internet.
It's been a pleasure taking this journey with you through the layers of the internet.
So we spent this episode unpacking the OSI model.
Yeah.
And we've explored its 7 layers and how they work together to make the internet the interconnected marvel it is.
Right.
But as you hinted at kind of earlier,
Yeah.
cloud computing
Yeah.
throws a bit of a wrench into things.
It does.
I mean, the cloud has revolutionized how we use and access data.
Right.
It's like this invisible force that's everywhere and nowhere at the same time.
It's a good point. The cloud definitely presents some unique challenges
Oh, right.
to the traditional OSI model. So remember how we talked about the OSI model being designed for point-to-point communication, where data travels in a neat and orderly fashion between 2 defined locations?
Yeah, kind of like sending a letter through the postal service.
Right.
You have a sender, a recipient, and a clear path between them.
Exactly. But the cloud operates on a completely different paradigm.
Okay.
It's all about distributed systems with data scattered across multiple servers and data centers around the world.
Right.
When you access a cloud service, your data might be hopping between continents before it reaches your device.
So it's less like sending a letter and more like conducting a global orchestra with data packets as the musical notes flying back and forth in a complex symphony of communication.
That's a fantastic analogy. And to make things even more complex,
Right.
cloud services often have multiple layers of software and virtualization on top of the physical network. It's like adding extra floors to our OSI building,
Right.
creating a whole new level of abstraction.
So where does the OSI model fit into all this? Does it even apply in this cloud-centric world?
That's the million-dollar question that network engineers are grappling with.
Right.
Some argue that the OSI model is becoming less relevant in the cloud era.
Okay.
It's seen as too rigid, too focused on physical layers,
Okay.
when cloud services are all about abstracting those layers away.
So it's like trying to fit a square peg into a cloud-shaped hole.
Exactly.
Right.
But on the other hand,
Yeah.
there are those who believe that the OSI model's principles are still valuable.
Okay.
Even in the cloud, it provides a common language for understanding network interactions, regardless of the underlying technology.
Okay.
And the layered approach can still be helpful for troubleshooting and security.
So it's more about adapting the OSI model to the cloud
Yeah,
rather than throwing it out completely.
exactly.
Maybe we need a new model, a cloud OSI model that takes into account the unique characteristics of cloud environments.
That's a fascinating thought. Maybe instead of 7 layers, we'll need 8 or 9 to account for the complexities of virtualization, serverless computing, and all the other innovations that the cloud is bringing to the table.
Yeah, it's definitely a conversation that's going to continue.
Yes.
As cloud computing evolves, we'll have to revisit this topic on a future episode of Tech Stack Lounge
Absolutely.
as things develop. But
Yeah.
for now, I think we've done a pretty good job of unraveling the mysteries of the OSI model.
I agree. It's been a pleasure diving deep into this fundamental framework of the internet with you.
And a huge thank you to all our listeners for joining us on this deep dive. We hope you've gained a new appreciation for the intricate workings of the internet, from those physical cables to the ethereal realm of the cloud.
And remember, whether you're sending an email, streaming a movie, or simply browsing the web, the OSI model, in one form or another, is working tirelessly behind the scenes, making it all possible.
That's it for this episode of Tech Stack Lounge. Until next time, keep exploring the fascinating world of technology, and don't be afraid to dive deep. You never know what amazing insights you might discover.
If you like what you're hearing, don't forget to hit the like button and subscribe. Thank you for your support.